This is video 2 in the topic simulation, and we are just following on from video 1 where we had already like random numbers given to us in a question. So in this video I want to look at a question where you have not been given random numbers and you're being asked to simulate a given problem or a scenario. So I'll show you how to do that, and as we will answer such a scenario using a question. So I'm about to share a question on the screen. That is our focus in this video. So this is the question we're going to attempt. Question 1 says, the Castor Manufacturing Company produces a product in a process consisting of operations of 5 machines. The probability distribution of the number of machines that will break down in a week follows. Okay, so that's a table below. Machine breakdowns per week, and of course the probability of those breakdowns. So machine breakdowns per week, so maybe like that they've just estimated that okay, there'll be maybe 1 breakdown, 2 breakdowns. That's what you're seeing in that first column. So they mean maybe three breakdowns in a week or 4, just a rough estimate. So now we've been asked, okay, part A, simulate the machine breakdowns per week for 20 weeks. Simulate the machine breakdowns per week for 20 weeks. So we have not been given random numbers, because whenever you are simulating you need random numbers. So if you have not been given, know that you are coming to use that random number table, which you should have, in order to simulate a problem. So what we're going to do is that I will share a screen of the random number table, and then I will show you how we pick numbers from that particular table and how we simulate over a 20-week period. One more thing to take note is that this question has not specified which column you will use in your random number table. So in an event, okay, when they haven't specified, then it should be a free choice. I believe so, because they have not specified in the question, so you can pick from any column. But if they specify, please follow suit with the rules that will be stated. So let me share the screen. So that's your random number table. As I said, they have got columns, okay. Column 1 starting with 13,962, that's column 1. The second column is, say, 79,92. Then third column 65,172. So if they specify, you just take yourself to the column where they've specified and you start working from there. Now in our case it was open, so it's free of your choice. So we'll pick one for the sake of this video. Let's go to column 1. Okay, so they said 20-week simulation. 20-week simulation. So what you're going to do is that, okay, you've seen how the random number is arranged. It's in like, okay, groups of 5, groups of 5, groups of 5. Actually going down the column, not in terms of rows. So when you're reading a random number table, we go down the columns. So like we said, column 1 starts with 13,962. That's the first column. So you just go down. That's basically how we'll be picking, go down. So like the first bunch has 5, the other bunch has 5. So those bunches of 5 are what we call lots, if anything. So they might tell, okay, just from the first lot, or simulating just 2 lots. Such scenarios, okay. Now in our case, it just told us 20 weeks. So what you're going to do is that, okay, you need to get each lot has only got like 5 numbers, so it will be like, that will just be for 5 weeks. So that's how you interpret this. You got the next lot, which starts with 83. That's what's still in column 1, mind you. We're just in column 1. We're going the next lot, which starts with 83,503. That's the second bunch, having another group of 5, right? If we get the first bunch and the second bunch, we have 10 also, 10 numbers, right? Okay, we've been told 20 weeks. We'll go the third bunch. There's the one starting with 06,936. Okay, that's the third one. If we add it on with the ones we've picked already, that's 15 in total. Let's get the fourth one, starting with 33,331. That one as well. We'll end in that lot specifically, the fourth bunch or the fourth lot. So that one is, after we sum up all those groups of 5s, we're getting 20. That's basically how we follow that instruction. 20-week simulation, we should have about 20 random numbers picked, in short. But are you going to be picking them the way they are coming, like the way we give an example, like the first digit in the first column is 13962? Are you also just going to grab 13962 and put it there? No. What will be happening is that we'll just be getting the first two digits from all those numbers in those lots, first two only. So you go like the same while using in column 1, the first two there, according to column 1, okay, there's 13. What's the number that comes after that 13? There's a 43905. Even there, we just need the first two. That's what I was meaning by just picking the first two. The third number, there's 005048. We also just need the first two. The next one, 61274, we just need the first two. 43753, we just need the first two. That's how you pick in a random number table, just the first two. That's it. So you find that so far of those first two we've picked, they've become 5, right? 5 components already, or five groups of 2 that you have just picked. That's just for 5 weeks if we're counting, because we've been supposed to do for 20. So I was supposed to pick of those groups of 2, pick 20 of those. So from the first bunch, we already made up 5 groups of 2. Got the second bunch starting with 83503. We only need the first 2, 83. Next, 36807. We only need what? The first 2. You pick 36. Next, 19, 1110, 110. We just need the first 2, 19. And you do that until you have about 20 of those first two digits. Roughly should end in that lot which starts with 33331. That's the fourth lot. Once you just pick the first two from there, you should end, because there will be 20 at that point. So after you've done that, okay, those are the numbers. So these are the numbers that you're going to use to simulate this problem to denote how many possible breakdowns that you will have in a 20-week period. So let me now share a screen so that you can now get to see how we'll do this problem using the Monte Carlo simulation. Okay, so I hope we're able to see this table on the screen, which is, of course, you start with just the way the table was given in the question. Nothing changes. Breakdowns per week, probability. Okay, you put them down. What next? Since probability was given, the work is easier. The next column should be cumulative probability. What's cumulative probability? It's just basically, probability that will keep on adding up. It's cumulative. So like to start first of all with the same number which is in the probability column, 0.15, but since it's cumulative, it will keep adding on. So the next figure was 0.308 in the probability column, meaning in cumulative it's going to be 0.15 plus that 0.30, giving you 0.45. Do the same thing. The next figure was 0.4, add it to 0.45, you get 0.85. From there, do the same thing and you have 1. So usually cumulative probability column should always add up to 1 as well, because it's a property for probability that you should never exceed 1. Okay, what next? You need the column for the random number interval. This interval is very key, and you'll see why it's in fact very key, as I'll explain very soon. This interval is just made as follows. Well, what happens is that when you're making this interval, our focus is usually on the cumulative probability. Like you start with the first cumulative probability, 0.15. Well, random numbers are not in decimals, right? Usually, as you saw in the table, they're just like whole numbers. So what you do is that, okay, these are decimal cumulative probabilities. Change them to, of course, a whole number. If it's 0.1, this is in fact these are percentages, 0.15. If you multiply it by each decimal by 100, then you will change them from being a decimal to a whole number, because there are percentages, and to change a percentage decimal to a decimal to a percentage of some sort, you have to multiply by 0.15 by 100. Sorry, let me just quickly show you what I'm trying to explain here. So if anything, what I was trying to say is that, okay, the cumulative probability is one we focus on when finding the random number interval. Now you notice that those are decimals, and when you're making the random number interval, you will not be using decimals, you'll be using whole numbers. So basically what you do is that you change them, like what you're seeing on the screen. Those are decimals, you need to just change them the nearest whole number. So a probability is like a percentage. It's viewed in form of a percentage. So to change that decimal into a percentage, you just multiply by 100 and it becomes like that, 15. Okay, so that would be like the first cumulative probability. The other one was 0.45. Okay, so you change it 45, and that sequence continues. So on the other side, we are seeing now 00 to 14. Why have I done that? So I'm trying to make a range. Okay, so we should have ended the cumulative probability just shows that, okay, you should end first of all, as of the first one should end on 15. But why am I not ending on 15, but I'm ending on 14? Well, we're starting from 0. Why we're starting from 0 is that you might also have random numbers of 0, 0. That's another reason. So that is why we are starting from 0 there. And once you start from 0, and it shows that the interval should be 15, 15 spaces, so including 0. If you count from 0 and 15 spaces, it will land you on 14. That's why we're ending on 14. So it's just a trick to remember that, okay, usually when we're starting with 0, we always subtract 1 from the cumulative total that it shows according to that particular line. Then you got the next one, 45. 45 was the second cumulative total. So you have that, okay, 45, meaning you should now end on 45, so they're just meaning. Now, since we've already been reducing from the start, that we started with 0, which has led us not to have ended on 15 because we're including 0, meaning the sequence will keep on deducting 1 from each cumulative that comes in. So it's like the next range will be like from 15 to 44. It's just a sequence, just get it like this. This is usually how we do up the interval. So even the other one will start, okay, from 45. So supposed to end on 85, there was a cumulative of 0.85 up, which is when you change it to 85 to end on 84. So we usually just subtract 1. Why? Because we started with 0. That is why we have done this, because the 0 gets to affect every other interval that comes, because that same beginning that we had subtracted from, we subtracted the 1, it has affected the whole sequence. So just remember, this is how it should come out. Yeah. So basically, that's how your interval looks like. Yeah, I hope the concept has been gotten on how to make a random number interval. And once you have done your random number interval now, what next? Simulate the problem. We had picked the random numbers as I was illustrating earlier in the video. So I'm just going to show you now how I have aligned them below the table. So they are here right below. Those were my random numbers according to the first column, which we're focusing on according to this video, since they did not specify. So I picked them up, okay, just like that. First two, just like that. Huh? There should be 20, so like 20 groups of first twos. Huh? Okay, then once you're done, what do? Go to the first, those same simulated numbers, start with the first two that you picked, 13. You ask yourself, this 13, you take it to the interval. In which interval can 13 belong to according to your random number interval? Well, it could definitely fall between 0 and 14, right? Yeah. So once you drop it there, you align yourself to that column where there's breakdowns per week, because that's what we're interested in, to simulate the number of breakdowns in a week. Yeah, per week, what they could be having in terms of breakdown. So according to the first simulation, you only have 1 and you put 1 breakdown. Next simulation, 43. Why could 43 be in the random number interval? You take it up. 43 is in the 15 to 44 interval. Follow the line. Which breakdowns per week are those? 2. You even put a 2 just like that. So you're trying to simulate the number of breakdowns using random numbers. Yeah, so once you do that, the process continues the same way, as you can see, and you're writing the answers below. Okay, once you are done, what next? Simulate the number of breakdowns in a 20-week period. So if anything, you're just supposed to end there when they say simulate the number of breakdowns in a 20-week period. You have just simulated, if anything. Those random numbers you picked from that column are demonstrated, and there should be 20 of them, 20 groups of tools. The only thing maybe that you cannot see clearly is there's a 99 there at the end. Suppose it's written as a 9 on those numbers that I had simulated there. It's supposed to have ended with 99. Yeah, just take note of that. 99, which falls in the random number interval of 85 to 99. When you check the breakdowns per week, you should have put 4. 4 should have been there. Yeah, somewhere there on that 99 random number. So when you just say simulate for over this period of time, they just end there. You've simulated those figures, you've put them below. For this random number, this is the breakdowns per week. For that, that's it. Then what I just did further, if you can see below there, I went further and did this where I said, okay, what's that 46 over 20 meaning? I went and now if they are and divided this over 20, why? If the question asks you that calculate the average number of breakdowns in this period, then you can do this. Those answers that you had found, like for random number 13, there's one breakdown. For 43, there's under 2 breakdowns. So you add all those simulated breakdowns. After you add them, they give you 46. Then divide that by the total number of observations. They're taking this in 20 weeks. Yeah, that's what you do. If you've been asked average, then you just proceed. Let me even just, and just as you can see, sorry, on the picture there, then you're done basically with the simulation.